Greetings and welcome, circleometricians of all ages. We're talking about circles here on my All Circles podcast special, December 14th. This is pretty great. 10.1, homework. I skipped the first few problems because I felt like it, and they seemed more vocabulary-based, and I felt like, let's just do this. 22. It says, tell whether AB is tangent to circle C. Explain your reasoning. So if I could prove that this is a right angle, then I would be able to show that it is tangent using our new theorem 10.1. In order to show that's a right angle, hey, this looks like a triangle here. And if this is 12, then notice this would be 12. And what is this entire length across, my friends? 20. So I'm going to say the following, using the converse of the Pythagorean theorem, is 12 squared plus 16 squared, is that equal to 20 squared? It looks like, do those just hold? That's just going to be 4 times the 3, 4, 5 right triangle. Yeah, so this is going to work. 12 squared, I know that one. That's 144. 16 squared, I already forget. Is that 256? Square it. Yeah. And then 20 squared, I feel like that's 400. Yeah, and 400 equals 400. So therefore, by the Pythagorean converse, this is a right angle. And because that's a right angle, then AB is... That's sad. I feel like I want a geometric symbol for tangent. I feel like I would draw an arc and a line. Like this would be my tangent symbol. I don't know. We'll have to workshop that a little later. So AB is tangent to circle C. There we go. All right, let's look at another one, friends. Oh, 23. Here we go. They tell us it's a point of tangency, and they ask us to find the radius. So this time I would do so using the plain old Pythagorean theorem, and I would say r squared plus 24 squared is going to equal, what is the length of this hypotenuse? R plus 16 is the entire length. So I'm going to write r plus 16 all squared. Beware, my friends. It is super illegal to distribute an exponent over addition or subtraction. So what formula you'd need to remember, and maybe you guys hadn't seen this before, I apologize if that was the case yesterday, is a squared plus or minus 2ab plus b squared. I'll do this out with a little bit more pacing, if you will. All right, so on the LHS, left-hand side, I have r squared plus 24 squared is 576. That is a great number. Delicious. And watch this. I'll take some time. So according to this pattern here, I'm going to use the plus version of the pattern. A is equal to R and B is equal to 16. So I'm going to take my time this time. So I'll have A squared plus 2AB plus B squared. So that's going to be R squared plus 2 times R plus, 2AB. So 2 times R times 16, my apologies, plus 16 squared, like so. Right? So that's going to equal R squared plus 32R plus, I just did this, 256. And that's equal over here to R squared plus 576. So now to solve for R, conveniently, there's an exact R squared on both sides. So I'm going to just be able to subtract that from both sides, and you guys won't be stuck having to solve a quadratic equation today. All right. And I got... All right, let's see. Let's keep solving. 576 equals... You with me, Jack? 32R plus 256... Subtract that 256 from both sides. Hi, Jack. Hi. How you doing? You know what? I'm afraid of subtraction, so I'm going to do this on my calculator. I feel like I really should be able to do this without it, but I'm on the internet and I don't want to do the subtraction wrong in my head. So out of like math phobia, divide both sides by 32. I will do this division in my head though. Speaking of which, Tom Clancy's The Division for Xbox One, pretty good game. I'm satisfied, but I'm only like level 18. I have not spent enough time on it. R is equal to 10 is my answer. So it turns out, right, this was a 10, 24, and 26 right triangle. Not bad, not bad. All right, let's keep moving on. Theorem 10.2, Duns-Cap theorem. It says points B and D are points of tangency. Find the values of x. And so if those are both tangent, then I know that they are perpendicular to their respective radii, and I know that they are congruent to one another. So therefore, 2x squared plus 4 is equal to 22 by the deafness of Kong. Minus 4, both sides. 2x squared is equal to 18. Div by 2. Right, you guys getting this? You feeling it, Mr. Krabs? Yeah. I haven't said that one in a while. I do repeat my jokes. Sorry. Root both sides. Technically plus or minus, don't forget it. Your algebra teachers will thank me for saying that. But I get x is equal to plus or minus 3. But because this is a geometry... Actually, wait! Wait, both of them are solutions for this. Because of the square. Both of them work! The negative one works! Wow. Whoa. Whoa. It's not a square, it's a circle is what he said. I like that. So yeah, in this case, actually, both of those solutions work. Let's see, was your book cool enough to know that? Let's see, what question number was this? 31? How do I am 31 already? They said plus or minus 3. Good for them. Wow. Well, what do you know? All right, last question. Prove it. Okay. I don't wanna, they said. All right, let's two-column this. All right. We can use Theorem 10.1, by the way, to be able to prove Theorem 10.2. So let's see. Here we go. Here we go. I've got my gimmies. Givens. All right. SR and ST are tangent to circle P. Because of that, that means that SR is perpendicular to RP, and ST is perpendicular to TP. All right? And the reason those are true is Theorem 10.1, which, by the way, the official name of that is tangent line to circles theorem. Because not every book would call that Theorem 10.1. All right, so that's why those are true. Therefore, I'm going to say angle PRS and angle PTS are right angles. And the reason that's true is def of perpendicular. Def of perp. And so I can label them right angles like that. All right, let's see how we can get clever. I'm going to say that I've got a couple more things here. Now, I want to prove SR is congruent to ST. I can't prove that right now. But if I knew that these two triangles were congruent, then I could use some CP/CTC. You know what I mean? I think so. So let's say this. I'm going to say that PR is congruent to PT. Why is that true? Yeah, I think it's like def of circle. All right. It's like radiusness. That's a great word. the radiusness of both of them on the same circle. I like it. All right, so those are congruent. I'm going to say this, and you guys will all know this one. PS is congruent to PS. Reflexive. Now, could someone tell me, let's see, first of all, let's label these triangles. Triangle congruent to triangle. I'm going to say triangle PTS is congruent to triangle PRS. Does anyone know why? You remember why? Was that what, chapter 5? Maybe? I don't remember. What do I know? I know these are both right triangles. Hypotenuse leg. And the only way I can use hypotenuse leg is because I knew that they were right angles. So therefore, those were right triangles. All right, and then because of that, I could say SR is congruent to ST by CPCTC. Corresponding parts of congruent triangles are the congruentness of one another. Thanks for watching, Internet friends. Have a great day.